Okay, students, we have sufficient lectures on theory and derivation in the chemical kinetics. Now, today we are going to discuss some crazy questions. Okay, so that in this question, we will come to know the concept we have studied, how to apply them, and what type of questions are coming in the examination, and what mistakes other students are doing, and what you should not do so that your seat is confirmed in your examinations. Okay, so I have carefully selected 10 beautiful questions and I will give you the thorough explanation. And but what you have to do, you have to answer yourself. Once after question is displayed, then you should uh, pause it and answer it. Then cross check with my complete explanation, because I will not only explain that question and all type of logics I will explain. Sometimes I will explain shortcuts. So going through the video solution is only better after you tried your own. Okay, see the question, try your own, then go through my explanation. Okay, that will be the best tool for better scoring, because once you made a mistake and coming to know its mistake, then it will be a great effectiveness. Okay, so shall we start the chemical kinetics question session? Okay. Okay, here is the very first and basic question. Normally I arrange them in the easiest first and slowly difficult question. Okay, so try to solve this. The rate constant of this reaction K is given, and if the initial concentration is given, then initial rate. Okay, K is given, concentration is given, and rate you have to find out. Okay, pause it, solve it, check your option, then go through the video solution. Even though your answer is correct, better I suggest to listen my explanation. Okay. Okay, now I am explaining. See here, the main problem is we know that R is equal to K into A to the power of something, okay, X. But until unless we don't know X, how you will come to know? K is given, concentration is given, R you have to find out, okay. This is what the question. Main problem is what is X we don't know. And when you see here, options are also very confusing, okay. So for that, the secret is here. Units of rate constant. Units of rate constant will tell you the order of reaction. Okay. Per second or second inverse is a unit of good first order reaction. Therefore, it is 1. Okay. From where I could come to know? From this I could come to know. Okay. And K is how much? 3 into 10 to the power of minus 6 into concentration of A is 0.1. So 3 into 10 to the power of minus 7. Very simple. Okay. So I have selected very simple but tricky question. If you come to know this logic, from here you should find out the rate constant. Then it is easy question. Okay. Ready for the next such cute question? Okay. Okay, this question is selected because this covers many topics in one question. Until unless you don't know the all topics, then you will not be able to answer this question. Okay, so let's go through this question. Which of the following statements true for the following reaction? Okay, reaction is given, rate law is given. Okay, rate law is also given. Then order and questions are there. Order of reaction. For order of reaction, we should consult rate law. Okay, here it is 1 plus 1 by 2. Oh, sorry, you have to pause this and you should try it. Okay, try it, then listen to my explanation. Okay, so for order of reaction, you have to consult the rate law. Okay, so rate law says that 1 plus 1 by 2, that is 1.5. This is correct. Okay, if it is correct, then you will stop it here. No, this is a patience checking question. Okay, if you are enthusiastic, you are going to get -1 instead of +4. Okay, so next, molecularity of reaction is 2. For molecularity, you should go through the Balanced equation 1, 1, 2. Okay, so molecularity is equal to 2. This is also correct. Okay. Then third one is by increasing the concentration of bromine 4 times. So it will be 2Br2, sorry, 4Br2. So 4 to the power of 1 by 2, the rate of reaction will become 2 times. The rate of reaction doubles. Okay. So that is also correct. That means all are correct. So what is the answer? All are correct. Okay. So it can be multi-correct option also and single correct. They will frame like this. Is it understood? If they wanted to give an integer, how many of the following statements regarding this are correct? Like this type of question, advantage is that they cover many topics and they will confuse you easily. Okay. Okay. Next question is for the reaction H2 plus Cl2 sunlight, H2 plus Cl2 sunlight to HCl. Okay, is think reaction is visible? Not visible. I will write it here. For the reaction H2 plus Cl2 sunlight, okay, and it is 2HCl. For this reaction, what we have to find out order of reaction is order of reaction is okay. Option A says 0, option B says 2, option C says 1, and option D says 3. Okay, so now I think it is easiest question. Try it, and I challenge that you will be wrong. Okay, challenge over. Answer is A. Why molecularity is 2? It should be 2. Is it understood or not? But the answer is here. Okay. So actually sunlight means it is a photochemical reaction. Okay. So photochemical reaction. You have to remember actually this is most not covered in most of the lectures also. That's why this question session. Okay. The points which I missed, which mostly missed by the video lecture by anyone, okay, because every minute point cannot be covered in the theory session. So for photochemical reaction, they don't depend on the concentration. Okay, photochemical reaction do not depend on concentration. Okay, depends only on but depends on intensity. Okay, but depends on intensity of light. Is it understood? So because of this, what is the answer? They do not depend on concentration. So zero order. If they depend on concentration, first order, second order, half order, like that, so many will be there. Okay. So add it to your theory notes also. From this question, you add it to theory notes also because very important point. Okay. Ready for one more question? Okay, next question is the rate constant. The rate constant K for the reaction. The rate constant for the reaction N2O5 gives 2NO2 plus half O2. Okay, for this is the reaction 2NO2 plus half O2 is rate constant is given 1.3 into 10 to the power of minus 2 second inverse. Which below, okay, which of below describes, change of square bracket means concentration, okay, change of concentration of N2O5 with time, okay, with time. Option A, N2O5T is equal to N2O50 plus KT. This is the option A. And option B, N2O50 is equal to N2O5 into N2O5T e to the power of KT. Okay. Option C, log N2O5T is equal to log N2O5 concentration 0 plus T. Okay. Next, fourth and final option is ln N2O5 divided by 0 N2O5 T is equal to KT. Okay. So these are the four options given. This is the reaction. N2O5 gives 2NO2 plus half O2. That rate constant is 1.3 into 10 to the power of minus 2 second inverse. Okay. So this reaction is given like this. And you have to select which option is correct. You can try, and I will tell you. Okay. Right? Okay. Now listen to my explanation. Again, the secret lies here. Secret lies here. Okay, because second inverse means first order. So first order, what is the formula? This is the formula. Okay, 2.303 is to be multiplied. 2.303 is to be multiplied when there is log. Ln is equal to 2.303 into log. Is it understood? And here 0 stands for initial concentration, T stands for amount left over after the time T. Okay, so you are finding T and 0 are not. 0 means initial concentration, T stands for concentration at T. Okay, so what is the correct option and why it is correct option and how you will approach is understood now. Okay, ready for the next question? Okay, here is the next question. For the reaction A moles of A react to give X moles of P. When concentration of A is 2.2 millimolarity, the rate was found to be 2.4 millimolarity second inverse. But on reducing concentration of A to half, the rate changes to, initially it was 2.4, now the rate changed to 0.6. Then order of reaction with respect to A is, okay, half, then rate changes to 0.6. Initially 2.4, then it is 0.6. And rate changes. Order of reaction with respect to A. Okay. So I will give you the options. Okay. I will give you the options, and options are 1.5. Okay. And second B option is 2.0. And C option is 2.5 and option D is 3.0. Okay, these are the four options. You can give a try and you can check. Already I've given you sufficient hints. When concentration is changed from 2.4 to 0.6, sorry, rate of reaction changes from 2.4 to 0.6 on changing the concentration to half. Okay, try, and options are also given. Okay. Right? Okay, no problem. This type of question you might not have attended earlier. That's why this problem may arise. Okay, so I am explaining this. Listen carefully now. So according to this, R is equal to K into A to the power of X. We don't know the order of reaction. That condition, what we will do, we will take it as a. Okay. Now R is equal to rate is equal to, first condition I am taking it as 2.4 is equal to, rate constant is given, not given. So I will take it as like this only. Initial concentration was 2.2 millimoles. Let us don't worry about millimoles. Okay. So this is 2.4. Let us take this as equation 1. And what will be the equation 2? Second equation will be 0.6 second time, but when rate of half, that means 1.1. to the power of x. Okay. Now what is our intention? We have to find out x value. So what I will do smartly, 1 divided by 2. Okay. 1 divided by 2, this will give you this time 4, 2.4, 0.61 ja, 0.64 ja. Okay. And k will get cancelled. This will get cancelled by 2 table. So 2 to the power of x. Okay. So, but problem is that here it is not in the power of terms. So I will write it like this. Is it understood? When bases are same, power will be same. So x is equal to 2. That means it is a second order reaction. Is it understood? So this is all about the fifth question. You have learned something new or not? Okay. Okay, next question is for the reaction 2N2O5 gives 4NO2 plus O2. Okay. Then the the rate of reaction, is, okay. Option A. Don't get excited with options. Your patience is checked in this option. dN2O5 by dt. Okay. Option B, 2 into D. I suggest you to control your emotions because these are all just checking with your emotion controlling. 1 by 4 D NO2. DNO2. Okay. By dt. And next, fourth option is 4 into D NO2 divided by dt. Okay. See, all options appearing to be very same. Okay. For this reaction. Is it understood? Now it is your time to control your emotion and check the correct option only. Checked, checked. This is not a calculation part, so directly you can answer. What is your answer and why is that answer? Okay. So let us see the option elimination. Is it correct or not? So this is the answer. No, what is the problem here? Minus sign is not there. If it is a reactant, minus sign should be there. That's why it is wrong. And here, minus sign is not there and multiplying by 2. And here, product plus and 1 by 4. This is the correct. Let me check. There is any mistake here. Problem is 1 by 4 should be there, but not there. Okay. So why answer is C. Is it understood along with the reason and approach? Okay. Ready for next question? So slowly, I will be improving the level numericals. Okay. Okay, here is another question. As I told you, there will be questions related to the graph. This is one of the graph. Okay. So go through it and it is a direct question. You need not to calculate anything. If you are not able to do, then you have to go through the video lecture containing that graph topic. Okay. So what is answer? Positive slope. I told you this is a zero slope, this is a positive slope, this is a negative slope. Okay. Intercept and everything it is clearly explained. Okay. So answer here I am explaining. For further clarification, better to go through the video lecture of this first order graph and answer is B. What is answer? B. Why it is? Go and refer. If you understand, you are smart enough. Okay, next question is T50 of first order reaction is 10 minutes. Okay, then starting with the 10 mole, 10 mole liter inverse. Okay, the rate after, very good question, rate after 20 minutes is, many concepts are combined together. 20 minutes is, okay. So half-life is given and starting initial concentration is given. We have to find out rate after 10 minutes is, okay. So by the time you solve, I will give you the options, okay. While you start solving, then I will give you the options. You can cross check with the options. Okay. Okay. Have you tried? Got it. See, you need not to simplify. Options are given so that you should not simplify, but options are very, 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 very confusing. Okay. Tried. Should I explain now? Okay. Half-life time is 10 minutes. Okay. And starting with 10 mole per liter, that is 10 molarity. Initially 10 molarity. And we want to find out rate of reaction after 20 minutes. So very easy question if you approach, if your approach is correct. Okay. So after every 10 minutes, in my previous lecture, there was a doubt by one of the student how to calculate the half-life time if they changes how the rate. So for that only I have made this. Okay. So 10 minutes. Then this will become what? Half of this, but and after 10 minutes, okay, it will become what? 2.5 molarity. Okay. Why I am taking only two times? Because 10 minutes, 10 minutes, 20 minutes. Okay. So after 20 minutes the concentration is how much? 2.5. Understood? So and it is a first order reaction, it is given. So what I will do, R is equal to K into A to the power of 1. Is it understood? Now, but K is not given. How you will do it? Very simple. K is equal to, for first order reaction, relation between half-life time and K. What is the relation? 0.693 upon T half. What is T half here? 10. Okay. And A is how much? 2.5. Concentration at that point of time. Okay. Is it visible to you all? Okay. So it is 2.5. Okay. So I will now, this is 0.0693, okay, into 2.5. On dividing, you according to the options you have to solve. Okay, don't solve as it is. Understood? So 0.0693 into 2.5. Is it understood, students? So which option is correct? B option is correct. 0.0693 into 2.5. Sometimes you should not blindly keep calculating. Okay. So ready for the next question? Okay, this is one of the lengthy question, one of the very good question. Calculation and trick both are combined here. The rate constant for this reaction is this one. Okay, if the start made with 1 mole per liter, that is 1 molarity of N2O5, calculate the rate of formation. So many twists. Rate of formation. Okay, rate of formation of NO2. Rate of formation of NO2 at the moment, not initially. Okay, at the moment, at the moment of reaction, at the moment of reaction when, okay, when concentration of O2, concentration of O2 is 0.1 mole liter inverse. Concentration of O2 is 0.1 mole liter inverse. Okay. Option A, 2.7 into 10 to the power of minus 4 mole liter inverse. Second inverse. By the time you calculate, then I will write the options. You can cross check. Okay. Option A is given and option B is 2.4 into 10 to the power of minus 4 mole liter inverse second inverse. Okay. Option C, 4.8 into 10 to the power of minus 4 mole liter inverse second inverse. And option D, 9.6 into 10 to the power of minus 4 mole liter inverse second inverse. Okay. So these are the four options. Very lengthy, tricky question. Why we are reaching at the end of the session. Okay. So slowly, I will make you capable of solving all level questions, not only simple level question, but the questions are arranged like that. You should initially will feel easy. Okay, tried and tested. Okay, now I will explain here. I will give you hint if you are not able to do this. Rate constant is this one. This is K. Okay, if we start the 1 mole of N2O5. Okay, so I will, with your permission, what I will do, I will erase this. Okay, I will write this value 3 into 10 to the power of minus 4 K. Okay, so I will write it here initially. Initially, how much? 1 mole. Okay, that time it will be 0, 0. And when concentration of O2 is 0.1. Okay, if this is 0.1, this will be 1 minus 0.1 into 2 or not. Its concentration. Okay, initial and at T is equal to T sometime. Okay, now the rate of reaction R is equal to K into concentration of N2O5 or not. And how I come to know this is one first order with the units. Okay, with the units I could come to know. And how it is used, is it understood? Okay, now we have to find out not rate of reaction, that also you should remember, rate of appearance of NO2. So many things are combined. So 3 into 10 to the power of minus 4. K value is 3 into 10 to the power of minus 4. N2O5 at the moment, this moment, 1 minus 0.2, 0.8. Okay, this is the rate of reaction. Okay, but problem is not, the question is not about the rate of reaction. Question is about the NO2. Okay, so but we know in the very beginning class only I told you R is equal to plus 1 by 4 into dNO2 divided by dt or not. So this we want on this day, this we want. So I will cross multiply. So this is equal to 4 into R. 4 into R. This is the R or not. So you can substitute R value here. Okay. So if I done like that, I got this as a 9.6 into 10 to the power of minus 4. How much I got? 9.6 into 10 to the power of minus 4. 4 into R. Is there any doubt about this? No doubt. Okay, very nice. Ninth question, up to ninth question we have covered. We are left with one more complicated, tricky question. Okay, be ready. Okay, next question is a reaction. RXN means reaction. Okay, which is first order. Which is first order. Okay, with respect to A has a rate constant A. Okay, has a rate constant 6. Okay, minute inverse 6 minute inverse. If we start with the concentration of A is equal to 0.5. Okay, when would it be? When would it be 0.05 mole liter inverse? Okay, time we want. When it would be means not something else. It is zero options I am giving. Question is over. Now you can start solving. Okay, question is over. Now you can start solving. Options are only additional information. Okay, so 0.384 minutes. Okay, option B 0.15 minute and option C 3 minute and option D 3.84 minutes. Okay, so this is the question. First order reaction with respect to A has rate constant 6 what will be the A 0.5. When it will reach starting is 0.5 and ending is 0.05. You have to find out time. Okay, right? Now it's my time to explain. Okay, solution. Actually, time for first order reaction is 2.303 upon K into log A upon A minus X. You can write. If you don't like this, what you will write is concentration of A 0 and A also you can write it. Whichever you feel like you write it. This is A naught and this is A. Okay, and you are provided with everything. 2.303 by K. K is 6. Okay, log. Initial concentration was 0.5 divided by final concentration left over. You have to be very careful. 0.5. Okay, so 0.05 1 ja, ye 10 ja, log 10 1 ja. Okay, so 2.303 23.03 by 6. Okay, what is answer? 2.303 by 6 into, sorry, log 10 is 1. So 2.303 by 6. Okay, so nearly 6 4 ja 24. Okay, so 24, that means nearby 0.4 it should be. So 0.4 answer is A. That is 0.384 is the correct answer. Is it understood? All the 10 questions were entirely different, not even matching with each other. Okay. So like this, one more session also I make so that all perfect in the questions. Okay. Bye bye.